This is an excerpt from my paper, Skeletons of a CTMU Unified Field Theory. This will be published in a book in the next year or so as a collection of papers exploring and defending the CTMU. You can find the paper linked in the description below. Special relativity builds itself from two opposing and well-established scientific principles, the principle of relativity and the invariance of the speed of light. The principle of relativity, originally formulated by Galileo Galilei, says that whenever something is moving, what one is really saying is that it's moving relative to something, some stationary object. Yet from their perspective, the observer is getting further away, not them. From a third perspective, they're both moving relative to another stable body. This throws our entire conception of position in space, upon which our experience and, in fact, science itself rely, into disarray. A stationary perspective is called an inertial frame of reference, meaning an object traveling at a constant velocity that won't change speed or direction unless acted upon by an outside force, where the laws of physics are the same for all inertial frames of reference. We thus must substitute our unstable notion of motion with motion relative to a rigid body of reference. A seemingly contrary principle in science is that the speed of light is 299,792 kilometers per second, a constant denoted by c, regardless of the inertial frame of reference. This was proven by Albert Michelson and Edward Morley years before Einstein, based on experiments regarding binary stars, which showed that the speed of light cannot depend on the velocity of the object from which it's emitted. Einstein's special relativity makes it clear that our concept of time cannot be separated from space and position. The CTMU takes this one step further and shows that time is the distributed processing or state transition syntax for space, which allows it to exist, evolve, and extend into the future through conspansion. Einstein introduces a t-axis, joining it to our standard xyz coordinate plane representing time. This means that every object can be treated as an event that exists in a particular position at a particular time. We can build a four-dimensional block universe by putting together every event that is, was, or ever will be into a static manifold, with each cross-section representing a frozen frame of three-dimensional space. We can briefly summarize Einstein's theory of special relativity by explaining that observers in relative motions have different viewpoints and thus observe different projections of the 4D block universe. As a consequence of relativity, the kinetic energy of an object can no longer be found by the equations of classical mechanics, which say E equals 1/2 mv squared, with E is energy, m is mass, and v is velocity. This equation must be transformed into the famous special relativity equation. It's E equals mc squared over the square root of v squared over c squared, with E being energy, m being mass, c being the speed of light, and v being velocity, which approximates the standard kinetic energy equation at low velocities. Yet, as you get close to the speed of light, it goes way off. Despite the clear genius and sheer vision of special relativity, it's evident that it needs a revamp. The trouble with relativity is not that it's untrue, but that it's incomplete. When we consider the view of the universe that relativity gives us, we end up with nothing but an arbitrary and deterministic 4D manifold that makes no distinction between past, present, and future, and thus cannot account for causality or generativity in any real sense. The CTMU metaformal system infuses every event with its metaphysical/metalinguistic identity through the conspansive manifold. It replaces the concept of an event, an infinitesimal point, with a syntactic operator that transforms the syntax of the SCSPL universe, creating reality according to the expression of teleology, thus bringing the events of special relativity into coincidence with the wave-particle duality of quantum metamechanics, and mapping both into the open top layer of the conspansive manifold/terminal domain T. These operators and descriptors take on physical extension through the geometry of conspansive spacetime. When you combine all these syntactic operators, instead of getting a block universe, you get the conspansive manifold, embedding the universe in a tapestry of infinite expansive potential through which it can exist and evolve. In a conspansive manifold, states never leave the overall manifold or primary point, as there's nowhere else for them to go, and are outwardly rescaled even as they have been replaced by new states and receded into the past, nesting and progressively interpenetrating as the manifold evolves. This contrasts with the special relativity four-dimensional block world, in which nothing at all changes in space and time. The CTMU adjoins a distributed mechanism of generativity to special relativity through which the universe can create new states within itself instead of evolving into a predetermined future. The future exists only as unbound potential, which is actualized by tellers and syntactors, not including syntactic operators/tertiary syntactors, which have no volition and only instantiate higher-order teleodynamics, with absolute self-generative freedom and self-modeling capacity with respect to configuration. transforming information about past states and collapsing this ontic potential into a new state according to its state transition syntax, which is syntactically equivalent to the universal distributed form of the God, through which the universe is endowed with a volitional capacity of its own, that of the primary teller/syntactor. And so while Einsteinian spacetime is incapable of the kind of generativity needed for ontic closure, its essential insights and formalisms can be easily mapped into Langlandian conspansive spacetime. Concerning this mapping, Langan writes, quote, "Spacetime, too, is ectomorphic, consisting of points called events, which are specified by 4 coordinates, 3 of space and 1 of time, that are separated by spacetime geodesics called world lines." But here's where it gets cool. Space-time can be overlaid on a continuously collapsed idealization of the terminal point set T of the conspansive manifold, the points of which are fully collapsed tertiary syntactors already conveniently coupled in mutual identification events. Space-time is just a kind of ectomorphic dual of the conspansive manifold. Space-time approximates T in the sense that objects move by skipping along time-like gradients, like stones on the surface of a pond, their paths effectively interpolated between points generated on their surface. But unlike spacetime, the surface itself is regenerated with each skip of the stone, or tertiary identity. And while spacetime can only confine its evolution to an ectomorphic scenario devoid of any extrinsic pre-geometric background, T resides on an intrinsic background, the non-terminal domain N. T is thus adjoined to the deeper structure supporting teleodynamics, which cannot reside on the surface of the manifold and is not actually supported there. So you have this breakdown into you have cause and effect, and what we're seeing, it's only the effect. That's what we're seeing with spacetime, but there's this deep cause, this programming non-terminal domain, which is actually creating and generating and potentializing our reality. In short, space-time is merely the tip of the iceberg, so to speak, and the true dynamics of the universe reside in the deep structure of the conspansive manifold. The CTMU embeds classical space-time in the non-terminal domain N, the world of design and potential, to adjoin it to the deeper structure that supports the necessary teleodynamics to create, evolve, and sustain the universe. All of Aristotle's 4 causes are mapped onto the structure of the conspansive manifold, providing its own physical material cause, metaphysical design, its formal cause, self-operation, efficient cause, and teleology, its final cause. Because each of these strata of causation is observed to occur at both the quantum and global level, the CTMU conspansive manifold is conceived as a joint medium for quantum mechanics and general relativity. The conspansive manifold is a metaformal extension of the theoretical framework of quantum field theory, a formalism which combines classical field theory, special relativity, and quantum mechanics. QFT describes quantum objects as excitations or excited states of quantum fields in a way obviously analogous to the inner expansion and requantization of the underlying quantum metafield of the conspansive manifold, in which the wave-particle duality becomes field-particle duality, as the field is internal to the points just as the points are internal to the field. Langan embeds QFT and general relativity into this quantum metafield, where physical systems superpose directly on deeper levels of metaphysical structure and dynamics. John Wheeler's famous saying summarizes general relativity: space-time tells matter how to move, matter tells space-time how to curve. This sort of feedback required for space-time curvature and thus gravitation can only be achieved through the conspansive manifold, which is dynamic with dual outward and inward gradients accounting for gravity, and the relative linear gradient of the conspansive manifold, which is dual to the time-like collapse, which is dual to the time-like collapse gradients of T, the terminal domain, which is equivalent to classical spacetime. The weak and strong equivalence principles in general relativity say, respectively, that one cannot distinguish between motion under gravity and acceleration, and that all physical behavior, this is the strong principle, is the same under gravity and acceleration. According to Christopher Langan, the CTMU meta-axiom, or master equation, reality int equals reality x of analytic reality closure, or ARC, which says that reality's intension and extension are self-dual to one another, thereby rendering reality analytically self-contained, can be regarded as a logical generalization of Einstein's equation, EA equals mc squared, with a medium on one side and its content on the other. General relativity must be affixed to an intrinsic background, because reality is a closed descriptive manifold. Any external background against which the differential geometry of general relativity could be affixed would simply imply the existence of a deeper level of reality to which the scale is intrinsic, and by which it is itself intrinsically explained as a relative function of other ingredients. Using a distributed syntactic tangent space, the structure of space-time is tensorially defined in terms of the masses and relative positions of its own material contents, resulting in an intrinsic, map-like metaphysical ontology principle definition of space-time. Unfortunately, the basic formalism of GR, differential geometry, is not self-contained with respect to time, as currently formulated. It tacitly relies on an embedding, conspansive medium to provide it with temporal potential. The CTMU can thus be understood as a hological principle of relativity, embedding the differential geometry of general relativity into each point of the intrinsic background of the conspansive manifold. Hology is a form of self-similarity whereby the overall structure of the universe is everywhere distributed within it as accepting and transductive syntax, resulting in a homogeneous syntactic medium. General relativity is thus formulated as a deterministic subtheory of the CTMU, related therein to a non-deterministic quantum subtheory. The intrinsic self-determinacy of the conspansive manifold itself relates the two. Christopher Langan writes, in the CTMU, gravity does indeed arise through the telic principle, teleology, and is described as a property of the conspansive and is described as a property of the conspansive manifold rather than as a force, the gradient of a classical potential. Because this property scales from the quantum to the global strata of matter and spacetime, one can thusly assert that the CTMU metaformal system is a theory of quantum gravity, a fact which, Langan once wrote, will no doubt eventually emerge. Christopher Langan writes elsewhere, the QM-GR relationship is defined by a convergent model, consistent interpretation mapping in a common framework, metaphysical structure, the CTMU. In other words, both physical theories can be simultaneously modeled in one metaphysical framework with some degree of overlap. Although a CTMU unified field theory seems within sight of a careful and intelligent reader of this paper, I believe the presentation of the high-level logico-mathematical structure of such a grand unified physical theory to Mr. Langan himself. Let the light shine forth in the darkness. May the peace of our Father in heaven be upon you. Like and subscribe.